I want to talk to you briefly about something called Simpson's paradox. We will not spend much time on this. But looking at this situation, it says we need a lawyer, and Roberts has won 90 out of 100 small cases and 10 out of 20 major cases. Phillips has won 19 out of 20 small cases and 75 out of 100 major cases. And who would we choose and why? We don't know if our case is going to be major or small, so how would we make that determination? So one option, one thing that we might want to look at is let's look at the overall total for each type of case. So for instance, 90 out of 100 for Roberts, 10 out of 20 for Roberts for major cases, same thing for Phillips, and then also the overall percentage, which would be 90 plus 10 out of 100 plus 20 for Roberts, which would be 100 out of 120. So find all of those percentages, and in doing that, we can see that if I looked at the types of cases, Roberts won 90% of small and 50% of major, whereas Phillips won 95% of small, which is more than Roberts, and 75% of major, which is more than Roberts. But if I look at my overall values, if that's all I looked at, I might be tempted to go with Roberts because he won 83% of overall. But obviously, in looking at the individual cases, it makes much more sense to go with Phillips because he's going to get me off of whatever I did wrong. So that's what Simpson's paradox is all about. It's just saying be careful when you average across different conditions. We had different conditions of small cases and major cases, and those conditions often change things, which of course we already found out with our conditional distribution, our tables that we made a little while ago. So just be careful, pay attention to not just the overall data, but that based on specific conditions.